Alright guys, welcome back. We're going to be solving another question from the second chapter of Meriam textbook. And in this one, we know that the masthead fitting supports the two forces shown. And we need to determine the magnitude of T, which will cause no bending of the mast, meaning zero moment about 0.0. So what we are trying to have in here, we have the moment about 0.0. We're going to call it counterclockwise positive equal to 0, and we're good to go to use our 2D shortcut that we have for finding the moment about 0.0. So first of all, we're going to break down these two forces in x and y components. So let's start with the 5 kilonewton. You know, this angle right here is 30 degrees, meaning this one will be 5 kilonewton times sine of 30 degrees, and the other one will be this one, which will be 5 cosine of 30 degrees. And same in here, we have two forces for T. One of them is T cosine of this angle here, alpha. And since we have this right triangle here, we know this side is 2, this side is 5, meaning based on the Pythagorean theorem, this side will be square root of 4 plus 5 squared, which is 25. So this will be equal to 29, and angle alpha is here, so the horizontal component will be cosine of alpha, which is adjacent to over the hypotenuse, which is square root of 29, and the other side will be T times sine of alpha, which will be 5, or opposite divided by square root of 29. So now we're good to go to find the moment. Let's start with the moment of 5 kilonewton force. So we have the moment of 5 sine of 30 degrees, and if we look at this, we'll see that it's going to make a counterclockwise moment about 0.0. So it will be positive, and the distance that we have is basically what we have from here to here. So this is the line of action. We're looking for this distance, which is 60 millimeter. If we want to have it in meter, we can divide by 1000, but we don't need to do the unit conversion for this question, because at the end we're going to multiply this by 1000 and it will be cancelled out. But let's just go with meter for now. So we're going to divide 60 by 1000 to get it in meter. So that would be the moment of 5 sine. We have also the moment of 5 cosine of 30 degrees. Again, we have a counterclockwise moment, so positive sign, and the distance this time will be what we have from here to here, which is 90 millimeters. So 90 divided by 1000. That's pretty much everything for the moment of the 5 kilonewton force. And if we want to go with the moment of the force T, we have the horizontal component, and as we can see, this time the moment is clockwise, so we have a negative sign T times 2 over square root of 29, and the distance will be again the 60 millimeter that we have in here. So 60 divided by 1000, and also we have the moment of vertical component, so 5 over the square root of 29, and this will be 120, which will be this distance here, divided by 1000, and this will be equal to 0. Again, as we can see, if we just multiply this equation by 1000, we can get rid of this 1000 that we have for unit conversion. That's why I was saying we don't need to do the unit conversion. And what we're gonna get in here is that we're gonna get 539.7 minus 133.7. T is equal to 0, and we can find our T in here, which will be 4.04. and since we have the force in kilonewton, we're gonna get a kilonewton force at the end of this question. And so yeah, that's pretty much everything for this question. Hope you guys find this one helpful. Let me know if you have any questions. I'll be happy to answer those in the comment section. Don't forget to subscribe to the channel, like and comment. It's gonna help me to reach out to more students. And you guys take care. I'll see you in the next video. Have a good one.